The addition rule of probability. This has to do solely with when you're talking about the or. So remember we had the and and the or the not and the or during this section. So now we're in the or part. And when we have the or, we're going to use the addition rule. And there's two times we're going to use the addition rule. And if the two events are not mutually exclusive, we use the addition rule, but then we have this special little piece here where at the end we have to subtract the probability of both occurring, and then we have the addition rule when they are mutually exclusive, and we'll try to separate and decide when those occur. Main thing to ask yourself is every single time, are these events mutually exclusive? Alright, let's take a look at this problem. When a single card is drawn from a standard deck, what is the probability that it will be a king or a diamond? So the question is, are these events mutually exclusive? And the answer is no. So we're going to say to ourselves, okay, what's the probability of being a king? Okay, so we're just going to come over here, and the probability of being a king is going to be, what is that? It's going to be 13 out of 52. The probability of being a diamond is going to be, my bad, I got that backwards, don't I? So that's not going to be 13, that's going to be 4 out of 52. Let's just cross that off, and we'll do 4 out of 52. Okay, so now, according to my situation and to my equations, let me go grab it. My rule says that if my events are mutually exclusive, then all I do is add them together. I would take the probability of a king plus the probability of a diamond, and I'd add them together, and that would be the probability of getting a king or a diamond. Well, the problem is that I can get a king that can be a diamond. So they're not mutually exclusive. So what we need to think about now before we move on is, what's the probability of getting a king and a diamond? Alright, okay, so how many kings are there that are diamonds? 1 out of 52. So now we take these three different probabilities, which in the equation has three different spots. 1 probability, 2 probabilities, 3 probabilities, and we put them into the equation and we solve. So when we do that, give me a minute to write this down. So what I've done is I've written this out. Here's the equation that we use if you want to find the probability of event A or a B occurring, and the events are not mutually exclusive. Then we take the probability of the first event, we add the probability of the second event, and we take away the probability that both events occur. By doing that, what we get is the probability of being a king or a diamond is the probability of being a king, which is, oops, I made the mistake again, which is 4 out of 52, plus the probability of being a diamond, which is 13 out of 52, and we take away the probability of being a king and a diamond. And with that said, we take the 4 plus the 13, and that's 17. We take away 1, and that's 16. So the probability of being a king or a diamond is 16 out of 52. Which then reduces to, let's see, 8 over 26, which reduces to 4 over 13. And that's your probability of being a king or a diamond.